So we continue the conference with our next speaker, Clemens Vasters. So from Germany, Clemens gives an update about all what's happening around one of his favorite topics, being Azure Service Bus. So over to you, Clemens.
Thank you. Did I unmute myself? I think I did. Okay. Great. Welcome everybody to this session about Service Bus. My name is Clemens. I'm the architect for the messaging services, and already gave a session that you might find in the archive yesterday about messaging patterns, but I also talked about Service Bus a bit. And I'm sure you've heard about Service Bus during the show already, so I will not try to teach you Service Bus. I'm going to give a brief overview in a moment, but I will talk about update. I will talk about new things that we recently shipped, and some of the things that we are about to ship, and some things that we are working on. And I will also give you some sneak peek on some work that is in flight, but that you will surely find interesting. So these are all things which are have been delivered or will be delivered within the next few months. On Service Bus. And there are several things that we're very excited about. In messaging, we have 4 core services: Relay, Event Grid, Service Bus, and Event Hubs. And I will be talking about Service Bus today, which is our queue-based service. And you should always look at those services as a family. So it's not about either or. Many customers use certainly Service Bus and Event Hubs together in applications, and also complemented by Event Grid. And those services also integrate with each other, and you'll see more and more of that integration. So it's never an either or, but it's always depending on the pattern of the arrows in your architecture diagrams, you will use the appropriate service for the respective connection. And so particularly in Service Bus, we're implementing the queue pattern, load balancing, assignment of jobs to a particular owner. The owner will then decide what the fate of that job is, and will then go and either complete the job and therefore retire the message, or will return the message into the broker so that it can then be presented back to someone else. And then topics give you built into the platform a very rich way to deal with events and also with jobs, to kind of distribute them, to do partitioning, to do filtering, to do routing, and you can create full routing topologies inside of Service Bus. And all those things are true for Service Bus, the 2 offerings that we have, which are Standard and Premium. Standard is the large airplane that you can they can book a seat in. So these are shared resources, very large clusters, and you are buying effectively capacity in them by using up transactions. We have a gating set of quotas that you can use per namespace, and then within those you can go and use your resources. You can use queues and topics. You pay effectively for the right to use Service Bus Standard a base fee of about $10 a month, and then you can use effectively as up to, I think, 50 namespaces as you like. You can create them, you can tear them down, they don't cost you anything. You can use those for dev and test. You can create them automatically as you're doing a test run, and then from there on we only charge you for transactions. And within that base fee, there are 12.5 million base transactions are included, and then you basically pay for overage. So it's a super cost-efficient solution for dev test, for messaging, but then also a very good solution for applications that don't require lots of throughput or very predictable latency. Premium is then more kind of the private jet. You get dedicated resources. We allocate memory and we allocate CPU to you. And then you can also pin this to the gateway for a premium namespace. You can pin that to one or multiple private networks, VPNs. So you can go and use Service Bus effectively as the bridge between multiple private environments, as a layer 7 router, if you will. It also has then extra features like full GMS support, which I'm going to talk about, and large message support, which I'm also going to talk about today. And there you pay not for transactions, but you really pay for capacity. You pay for the memory and the CPU and the I/O transactions that we reserve for you. The first thing I want to talk about is specifically for Java developers and application developers who are configuring platforms that are built on Java. And it's a bit of an odd topic because in Azure, we have more or less progressed to treat all the programming languages as equal with Python and Java and JavaScript and C# or .NET languages in general. And so it's a little bit odd to go and talk about Java in particular. But the fact of the matter is that many of our customers who are bringing workloads to Azure have particular interest in Java. And JMS is the most successful universal API for messaging. And that is almost, it's very often called a protocol, even though that's not correct. It's just the interface. But it's so prevalent that supporting JMS is something that is effectively table stakes for any messaging platform. And on Service Bus Premium, we now make JMS available. More precisely, we have added full JMS 2 compliance, and we've shipped this at the beginning of this year. So in finance, in retail, commerce, government services, most of the customers that are coming to us, enterprise customers, have very heavy investments in Java and are running most of their enterprise workloads in Java. So therefore, we have decided that we want to not only make them somewhat compatible, or really become as compatible as we can to the core spec of JMS. Not all brokers are really completely compatible with JMS 2.0, but we've gone as far as we could. So that if you have workloads today that are built on IBM MQ or TIBCO EMS or Red Hat AMQ or any other JMS compliant broker, the goal is that you can go and take your workloads and simply switch them and then use Service Bus. That's something we can do in Java and with JMS because there is a common interface. So that common interface does not exist, unfortunately, in .NET, which makes that switch much, much harder because there is no common way to speak to any of those brokers in .NET in this common way. There's an interface called Apache NMS, which is something that's an effort that's been started by, I think, Red Hat a while ago, but hasn't really progressed much, and which is effectively modeling the same interface for .NET. But there is, of course, alternatives. I'll name them here in the form of like Mass Transit and Service Bus and other frameworks that are providing a somewhat similar experience, even though not quite as direct as JMS on .NET. And we've also decided to include effectively starter documentation for Service Bus for those frameworks. So you will see that pop up in the Service Bus documentation fairly soon. And if anybody has kind of the same kind of abstractions for other languages, then we'll be happy to talk about that and also include that in the documentation. But those are the most popular ones effectively that are being used in .NET. If you the customer is coming, if you are coming from IBM MQ, TIBCO EMS, Red Hat AMQ, or some other JMS broker, may that be ActiveMQ or RabbitMQ, and you're coming through JMS 2, and you're coming to the cloud, you'll find that Service Bus is more available, more reliable, more scalable, and at the same time, vastly more cost efficient than any of the brokers that it currently run. And that's something that most customers who come to us observe in a similar way. And we see vast movements of workloads from on-premises data centers into Azure, which are largely unchanged, which means customers bring their entire VM stable of VMs and just effectively create virtual networks and install the software as is, more or less, from the data center onto Azure. but then they go and effectively leave their message brokers. They want to leave their message broker infrastructure, which they have on premises, behind, and switch to Service Bus as an alternative broker as the first PaaS service they adopt. So that is emerging to be a very common pattern, that in lift and shift, even if you don't change the workload much, that the desire is there to adopt Service Bus as the core message broker, as a PaaS service. And that's also what has been driving us to invest in JMS compliance. Full compliance is a huge hurdle for any broker. There are not a lot of brokers which are fully compliant in the way that we are. And we wanted to do this in a way that is not only beneficial to JMS customers, but really benefits the entire ecosystem. And not only the Service Bus ecosystem, really, but the entire messaging ecosystem. So we did a fairly complex setup here. We worked with Red Hat in particular in the AMQP technical committee in Oasis to build 7 complementing specs for AMQP. So AMQP, the core AMQP spec has not been touched, but we've been effectively extending it. There's now a common addressing model. There's now a common filter model. There's now a common way to deal with connection uniqueness, which is a requirement for JMS. So a number of enhancements, complementing capabilities, which were necessary to really be compliant with JMS. So we worked on those together. And then we started working with Red Hat, supporting them and also consulting with them on the Apache Cupid JMS provider, so that not only are we following the model of JMS in the way that there is an interface, and that's the same between, let's say, IBM MQ and Service Bus, but we are sharing the code for the JMS provider with 2 other brokers, and that is ActiveMQ, and that is Cupid, and then Service Bus. So Service Bus and Apache Cupid and ActiveMQ are actually compatible at the wire level on the basis of AMQP, based on these AMQP, on the base AMQP spec and those extra little extensions that we built together. The great thing is that all of those additions that we made for JMS compliance will now also be available through all SDKs and not just through Java JMS. So we're about to start that work, or we have started with some of that work, and I'll enumerate some of those things now. But and that's something that is started motivated by this legacy API, if you will. But it's really an investment that we made in the future, and you're seeing the first glimpse of that in the JMS support. So when I'm saying, as the subheader here says, it's the biggest single feature update since 2011, that is the truth. We just added a whole host of new features to Service Bus, but not all of them are visible through the native APIs just yet, because we launched them effectively with the JMS support. So what did we add? You have temporary queues and topics, which are named by the server, and they have exclusive receive access by a creating party, which means a client can now go and just start creating a temporary queue, and the temporary queue is then automatically affiliated with that client. Nobody else can receive from it. And then the lifetime of that temporary queue is constrained to the lifetime of that client. And in the first step, that means the lifetime of the connection, but keep that in mind because I'm going to get back to it. So that's what the automatic cleanup means. So you create a temporary queue, you can go and take the address of the temporary queue and can make this the reply to address. So you can go and automatically create a thing in the API without having to go through Azure Resource Manager. You simply go and make an AMQP gesture, and then you get a queue back, you get a queue address back, which has been assigned to you, is guaranteed to be unique, and you can use that as a reply to address into your own process. The same is true for topics. On those topics, so on those temporary topics, as well as on normal topics, which you can also create now by effectively just attaching a link, creating a receiver into a Service Bus, you can now go and create ad hoc topic subscriptions. So if you're familiar with the way how, for instance, MQTT works, there's a topic and you simply go and create a subscription which immediately causes the messages to flow. You can now do something very similar on Service Bus, where you don't have to go and pre-create a subscription through Resource Manager or through a management API, but you can simply start receiving, if you will. You can simply open up a listener into a topic, and that will then deliver messages back to you. And there's multiple types of these subscriptions, so that you can go and create a completely volatile subscription that will clean up and go away when you are disconnecting, or you can create a subscription which is also private to a particular client with a particular ID, but that can actually go and transfer over to another machine, so that nobody can go and steal your data, but you can go and fail over to that particular machine. We also support, and that's something that we are required to do for compliance, the JMS message selector syntax. We have that allows you to have direct portability of filter expressions that you may have embedded in applications. So there are several aliases in JMS message selector syntax for instance, the JMS underscore message underscore ID, the message ID. So all of those abstractions are now also supported. And one of the cool things about message selector support in the JMS API is that you can do conditional receives also from queues. So with adding that support, our queues in Service Bus now also support those conditional receives. You can go and create a receiver on a queue. You can give it a message selector, which means a SQL expression, and then you will only get those messages which are eligible per that message selector from that queue, and you get that without head of line blocking. That is effectively the same functionality that we have for sessions today. Sessions are faster than this, I should say. So that you can go and effectively use demultiplexing, or you can go basically just pick out messages from a message stream from a queue without having to split it into a topic. And that is still, you don't get copies, but you basically just get the individual messages out. So that's something that is not the fastest feature in the world, and something that we will advise you to use fairly sparingly, but it's a cool feature nevertheless. Another thing that we also have done, and that's something you'll see percolating through the other APIs, is that we've revised the way how we do transactions. So today, in our current APIs, there's a mechanism to use what we call send via for realizing transactions, and you have to do this explicitly. So the way how this works today is you choose a primary queue, which is your transfer queue, and you can go and pull messages out of that transfer queue, and then you can go and send messages as a result of that transaction via that transfer queue into the target queue where you want. But the transaction is all focused on that one entity, because we can only make transactions happen on one log. That has been somewhat confusing, and it's also not working at all with JMS, because JMS has a notion of transactions that go across entities. So we've made protocol changes that allow to make this transfer model that sits under the covers go away. And so we have a set of rules. So you start receiving from one queue, and then you can go and send to any number of other queues within the scope of a transaction, and commit this atomically as if you had sent to all of them. And under the covers, we're doing this transfer model via this lead queue magically, so that we can go and guarantee that atomicity at the broker level. So you get normal looking JMS transactions, and the result of that is that you will also get completely normal looking transactions in .NET and all the other native SDKs down the road without having to worry about this via mechanism. We basically just optimize that away. What is the effort for JMS? You take effectively an existing application, and then you take the Azure Service Bus JMS Maven package or the Spring starter for Azure Service Bus if you're running on Spring. You change the configuration or the app properties for Spring to set the Azure Service Bus connection string, and then you can go and use Service Bus. So practically speaking, it looks like this. You effectively are replacing your existing JMS provider with a reference to using Maven, using Azure Service Bus JMS, and then you're using the Service Bus JMS connection factory settings and the Service Bus JMS connection factory. You'll notice that this is a class that's specific to Service Bus, and I spoke of the Apache Cupid JMS provider. That is the code that's underneath, but for some extra functionality, especially also with the authorization models that we have, we had to kind of overlay that with a bit of a shim, but the goal is that we will make that delta go away, and then ultimately it's going to be effectively exactly the same code between those two, but we'll probably reserve the flexibility here and just keep those classes. But at the bottom, the bulk of the work is being done by that shared Apache Cupid JMS provider. So switching away from Java and Java JMS, in case you missed it, we also shipped in November, so a little earlier than that. So that's about half a year ago, a little bit more than half a year ago, the fourth generation of the Service Bus API, fully integrated with the Azure SDK. The most exciting thing that for me is in the kind of work that I do is that we have single sign-on with Azure AD. And if you are building applications that are picking up the user context, for instance, or the machine context, you don't have to worry about credentials at all. So the only thing you have now to go and configure is really the endpoints for Service Bus, only the addresses, and then all the credential stuff goes away. And you'll also see this in the API, reflected in the APIs. We're making the connection string is becoming less loaded, and the connection string is becoming less interesting, because the connection string, the interesting part really is only the endpoint. So the only thing you need to worry about is really the fully qualified name of your namespace, and then the information within it, because the default of protocol is AMQP, and the credentials are now something that is happening kind of outside. The great thing about that new SDK is also that we are sharing the AAD context with all the other APIs. So there's no more, use key, that kind of key for this, and that kind of key for this, and this kind of construct with AAD for that service and that for that. It's all harmonized, all the same, which means you can log in once in a context and then interact with that same context using Service Bus and with Azure Blob Store. You would think that it would have taken us less than 10 years to get to this point, but here we are. So I'm glad that we finally got to the point that we have this harmonized. So one user login, and then you're only dealing with the resource names. In those new SDKs, we also did some alignment of terminology. For instance, we have a message property that in the prior SDKs, which is called label for a message. The name label actually stems from MSMQ. And we kept that around for a long time as since customers came from MSMQ for a long time. And now we decided to switch that over because the term for this is subject in AMQP, and this has become a point of confusion. So we effectively aligned some of the remaining holdovers from MSMQ. We switched them over to AMQP, which has become our primary messaging, our primary protocol, and so therefore we're aligning those things. Another thing that's great especially if you're working with interoperability focused projects, is that even though we keep the SDK structures, the service bus message, for instance, fairly simple and very focused, you now have a function that allows you to get at the entirety of the AMQP message with all the details. So you can get at the annotations, delivery annotation, as well as message annotations. You can get at the footer. So if you wanted to go, and you can also go and construct a service bus message on top of these AMQP messages, which means if you were building some very sophisticated apps on top, if you wanted to do end-to-end encryption, where you store signatures and key hints, etc., in a footer, for instance, you can now do this because we give you access to the underlying pieces without you having to drop down to the lower level of that stack. All of those APIs are not now completely on the same level. It used to be that the C# API maybe had a bit more love, and Java, and then Python and JavaScript probably didn't. That has now changed with that new SDK. They have all dedicated teams, and they keep being kept on level. And we also have dedicated architects who make sure that we have the right idioms for the particular languages. As I said, release was announced November, release December 2020, and Azure Functions and Logic Apps are going to pick up those new SDKs and all of those new clients and the new client classes later this year. And I have read, I think yesterday, that might be before August. So we shall see how that works out. So that's coming. Just a very brief look. This is JavaScript and a node. You have a service bus client, you create a sender, and then you send messages. You can go and create a message batch, and there's a batching API that's always built in all of those clients, where you can go and start trying adding messages. And this is gated by the allowable message size that is configured for the broker. I'll get back to that and what that means in a moment. And then receiver, we have a message handler model here where you can go and basically just subscribe. You are giving these error handlers and the message handlers, and then you're being called for whenever a message shows up. So that's this reactive programming model. We also have a programming model that's imperative that you can call receive. So that's JavaScript and Node. Python is similar. You have a service bus client. It's always named in a similar way, but this is now, you see, more idiomatic for Python. And again, here is a enumerator model that is also effectively giving you a way to be called back, if you will, because these the service bus receiver instance is a generator, so that kind of keeps that loop going. Java. This is the native client, not the JMS client. The native client gives you a similar experience as the other languages are. Service bus sender client. There's a builder model here. It's the same thing that you will also find in .NET. Send messages. There's a batching model that's very similar to what you've seen in Node. And then we have a processor client, which is the way how we have this reactive programming model. Again, there's a callback here. This is that callback that's being configured over here. And there's an error handler. So this is very similar from an experience perspective to what you just saw for Node. For .NET, it's interchangeable. Service bus client. You have a sender, service bus messages that you're dealing. So here the story is very, very, very similar. So if you know one language, you also know the other language. It's all this context, the terminology is aligned, but the clients are still idiomatic and also integrated with frameworks on the respective platforms. That much on programming languages. We're adding some stuff. So let's talk about some new things which haven't been released yet. You will soon be able to send up to 100 megabytes per message in Service Bus Premium, including JMS. The way how we're going to do this, so we have announced this and have spoken about this also in public for about half a year now as a feature that we're going to release real soon now. And then we found in beta testing, or in private preview testing, I should say, customers doing some fairly creative things with our quotas, where they were effectively using our quotas as a way to kind of fill up messages, and they were trying to send them, and if they could send them, then they were going bigger and bigger and bigger, weird patterns. And we then ended up with a situation, particularly also with scenarios where the clients are older and have been using the SBMP protocol, the prior protocol, is that applications were not expecting such large messages and then ended up exploding because the messages were too large, because there were buffers, internal buffers that were expecting never to go over 1 megabyte, all kinds of scenarios. So that's why we said, no, we have to hold this, and we have to go a big bit back to the drawing board. And here's what we ended up with. For each queue, you will be able to configure the maximum message size in kilobytes, up to 100 megabytes at the entity level. The default is going to be 1 megabyte, and all the current namespaces that you have in Premium will have this 1 megabyte. You can go and take any queue. You can go and upgrade that effectively to allow for a larger size, but so that your application is not going to be overwhelmed or surprised. So you have to go and do this explicitly, so that you don't have any undue surprises. From a perf perspective, sending very large messages over 100 megabyte will not be the fastest thing in the world, but that's also not what you will use that for. It's really there as a lift and shift feature. There are many customers who are coming to us with existing applications that are coming from IBM M-Cube in particular, where they're sending very large documents, 25, 50 megabytes through queues. And so if you have a scenario like this, you can go make queues that have that particular capacity, and you can do this without relying on the claim check pattern. Again, small messages are good, and don't start using these large messages as a thing that you do all the time, but really use them sparingly as a tactical measure for if you need to get data from A to B and there's really no other good path. Another feature we're adding soon is what we dubbed Durable Terminus. And Durable Terminus is a theme that comes from AMQP. In AMQP, the terminus is the endpoint effectively at which the other side is attached. And the terminus holds conceptually all the information related to a relationship between a client and the broker, for instance. And that includes all the messages and the state of the delivery state of the messages that have been assigned to that particular client. Today, with our broker as well as with most other brokers, it is so that when the connection drops out, all the state that has been associated with that connection is gone. That means that if you have a message that you got and you have under a lock, and you're working on that message, and now the connection drops out, that message will be, as soon as the broker detects that the connection is gone, the message will be released on the broker side and then maybe assigned to someone else. And then you as the client will only know this once you've tried to complete the message, but then run into a failure because the connection dropped. That behavior is okay, or has been okay for very long, because we were dealing with VMs and we're dealing with very stable connections. And if you have a connection, a TCP connection within a data center, that TCP connection is typically very reliable, and you can keep that alive for a very long time if you do a little bit of traffic. With containers, with sandboxes, specifically with Kubernetes, and even more with service meshes, we've now put tons of layers and indirections and layer 7 stuff between the broker and the client, so much that connections break all the time, which means that it's poison for the reliability of your application. So what we will do with durable terminus is we will make those connection drops completely survivable. We are effectively abstracting, we're using the existing AMQP model for this. We're allowing for connections to drop out under a link, for that link to continue to exist. And the clients will automatically reconnect and effectively rewire the link without you even noticing. That means that all the in-flight work that you have, all the even all the message receipts will still be there even though you lost the connection. So if you are on a congested wireless LAN or LAN connection, if you are in a container, if you are behind a service mesh, if the NAT reboots, if any of those things happen, then the SDKs will be able to silently recover the connections under the covers, and will then effectively reconnect the links that have been established. And all that link state will be saved in the server. That also means, as a consequence, that message locks that we have today, which you have to renew in Service Bus, that renewal will no longer be necessary, because the message lock renewal really exists for the disconnected model as you have it with HTTP, and then also exists for the model for where we can go and drop a connection occasionally. And then we need to have a timer effectively to deal with those connection drops. By making those links more reliable, we can omit those renewals, and we can make this completely dependent on the lifetime of the link. And we will also then associate policies with the lifetime of the link. You can choose whether you want to have an expiration on your message logs, or whether you want to make them effectively live as long as the link lives, and you want to make it explicit for those links to go away. You can make a message processing work. You can make that last for 4 hours if you need to. And we have some customers who actually need to have those very long processing times. So that's something you'll be able to do with a new SDK once we added the feature. That's something we're working on today. And operations will no longer fail on lack of connectivity. If you have a send operation or if you have a receive operation and the connection dropped out, unless you have a timeout, it will simply not complete and wait for the connectivity come back. And ongoing transactions, so this also spans the transactions, that will also not fail, because we can go and also repair effectively the entire transaction state on top of those broken connections. So this is that's work that we're doing, and it's pioneering work. There's no other broker, even the AMQP brokers, which does that, because we know that this new world with containers and service meshes and sandboxes, etc., is far more brittle. But we want to provide world-class reliability, and so therefore we need to go and do the work to make the connections effectively survive. And then a further topic, and that's also coming with news, is federation and replication. We added at the beginning of the year fairly extensive guidance to both Event Hubs and Service Bus for how to deal with multiple sites, deal with replication, and because we have very, very many customer conversations that start with, I want to have a backup of Service Bus data on another site, and then end up in a discussion that is really about active-active, because the case that an entire Azure availability zone region dies is not as likely as connectivity from some site to that data center failing. And so then you don't want to go and move your entire workload from one data center to the next, but you really want to use an alternative data center with some other resources for temporarily, or you want to go and switch over for good. But that requires that you operate multiple footprints concurrently. And so to be able to go and move data between those footprints, that's why we wrote that guidance. So you'll find that under the context of multi-site federation in the Azure Service Bus documentation today, and also in the Event Hubs documentation. One aspect of that is that we are using Azure Functions in the guidance and logic apps to move the data. And the reason for that is that we also observe that there's a lot of scenarios where you need to go and do a touch-up of the message, or where you want to go and do a little bit of transforming, or where you want to go and consolidate, where you want to go and transfer from JSON into protobuf, or from protobuf into JSON, where you want to do a little work on those messages. And so we are harmonizing this whole, and we've considered like extending the forwarding auto forwarding feature of Service Bus to also go across namespaces. We've considered numerous other options, and then we landed on a very fine replication engine that we already have, and which is really well tooled, and that is Azure Functions and Logic Apps V2. So all the guidance is focusing on how can you go and build a very smooth replication experience with those technologies. And to make that super easy, and this is something I'm going to show you now and haven't shown really anybody else yet, is we're going to put this into the portal experience in a very seamless way. So you will see, and this is not done yet, this is effectively a sketch of how this will look. This is Event Hubs, but this will look exactly the same in Service Bus. You will find that there is an automation task tab where you can go and start adding a task, and then you're going to get a page that says replicate to an Event Hub. You will also be able to do that from Service Bus, or replicate to Service Bus, which is not shown here. Replicate from an Event Hub, or replicate from Service Bus. You're going to also see that here. So there's going to be some templates, and you're going to pick the template, and then you can go and effectively configure the source, configure the target. The source is going to be implied. That's the host, or the source, depending on what the template is. So one of them will always be pre-connected. And then you can go and effectively connect your target. And once you've done that, you land here, and then the hint that this is going to be powered by Azure Logic Apps is going to be here. We will go and effectively pick the app plan for you. There's going to be a default app plan that we're going to pick. And then all of your replication tasks will land in an app plan and then run inside of there. And you can go, you'll be able to monitor that with App Insights. We're going to have a marvelous visualization for those replication tasks where you can see the latencies, et cetera, as those things integrate. So that's something to look forward to, and that is going to be the smoothest experience you'll find for messaging integration across Event Hubs and Service Bus, and between Service Buses and between Event Hubs, that's available in any cloud platform. And then something else, another topic that's important. We are getting a lot of requests to only allow for TLS 1.2. The reality is that Service Bus has been around since 2010, and we are pretty serious about being committed to backwards compatibility. And TLS 1.1 is weak, but not entirely broken. TLS 1.2 and 1.3 certainly improved massively on it. And but there is a lot of workloads which simply sit in the corner and talk to and through Service Bus, and we're not going to go and kill them all. So that we need to have a different way to deal with TLS version switches also into the future than just go and indiscriminately kill all clients. So what we'll do is we'll give you a switch for the minimal TLS version at the namespace level. You'll still be able to negotiate a connection with a lower, whatever the client has, right? So if the client goes and says, I'm going to do a TLS 1.1 with you, we will still negotiate that socket. But then if the policy at the namespace level says, no, this needs to be 1.2, then we will instantly go and disconnect that socket again. So you can go and negotiate the socket, but once the socket is done and is handed off effectively to the Service Bus gateway, the Service Bus gateway will then look at it and say, no, we're not going to want to work with that socket. We'll go and disconnect it. So that's something we're also going to add in the immediate future. So summarizing, Service Bus is a fully managed path service. As you know, with JMS, it is a very viable version to throw away your legacy brokers. I should also point out that for many customers who have a data center in their backyard, it is actually a fairly viable alternative to use Service Bus in the cloud and then connect that and use that for the workloads that run on premises, because very often those workloads are distributed across multiple sites. And whether you run an MQ cluster in some location or whether you run a Service Bus in the cloud doesn't make that much of a difference. And there's a little secret that we have, and that is that egress charges that you usually are charged when you run VMs actually don't apply for the messaging services. So you can run your broker in and out without being worried for that extra cost. And of course, we're running that at enormous reliability. I looked yesterday, the 30-day reliability for Service Bus overall is at well over 5 nines. And that's something that is more reliable. And there are no service windows, right? Service Bus doesn't go down. And so therefore, that's the most reliable option. Service Bus resources, you'll know where to find them. Go to the, Google for us or Bing for us, Azure Service Bus. You'll find the documentation. There's a few resources here. JMS getting started in particular. And then if you have any questions, you can always send email to askservicebus@microsoft.com. Mind that that's not a support channel. If you have a problem, especially if you have an acute problem with Service Bus, please always file a service request through the Azure portal, because that's the way how you can also get to someone immediately who can help you if you have a production issue. And with that, thank you very much for your attention. And Kevin, do we have any questions?
We have a number of questions in the Q&A. Look in the accepted section. I left a bunch for you and answered some.
Okay, let's see whether I find the right window here. Meanwhile, can you read one to me?
Sure. I will go through the first one, or let's see. If there are temp queues and topics, what is the TTL? The
TTL, the temp queues and topics are by design. You can go and set the TTL today. So we have a feature that is, you can set the auto expiry on queues today. The implied temporary queues and topics for JMS, they go away when the connection goes away. That's the extra work that we're doing here. And you'll be able, at the MQP level, you'll be able to go and set a policy and say that the entity will go away when the connection drops or when the link goes away.
Great. Are receiver created topic subscriptions only available for JMS 2.0 or for the .NET SDKs as well?
They're not yet available for the .NET SDKs, but they will be. And we will also, in the coming, I want to say weeks, but realistically months, and that's just a getting it done thing, we will completely document how this works at the MQP level. So you'll be able to do this with any MQP stack. So all of the features that I enumerated for JMS will also be available on all the other languages, and we will completely document how to do this in any MQP stack.
Any of the cool features, ad hoc queues, et cetera, available when consumer is forced to use SB REST API?
No.
Easy one. This next one I don't understand. Namespaces.
And let me add one thing on this, right? If you're forced to use the SB REST API, that is often based on firewall concerns, which should not be an issue because we run AMQP over WebSockets. And then if you're forced to use REST for any other reason, then whoever tells you that is simply ill-informed. Next.
How does lock time on the message have an impact on durable terminus?
The lock time on the message will be something that is like once durable terminus comes along, The lock times will be the lock times that the durable terminus gives you. Effectively, the lock time will be aligned with that of the durable terminus. So the terminus has an expiration, and all the locks are going to be anchored on that terminus. So the messages will effectively not expire by themselves.
There is a known error that sessions get lost when Logic App switches servers. Will this be addressed by durable terminus?
I'm not aware of that bug, but if that is so, then that is the way how that's going to be addressed, yes.
I think last one. Was the durable terminus chapter meant to imply that a peak locked message that intentionally is not completed on failure and expects to be requeued will no longer work because locks don't expire?
No. So we will have a we will make those things compatible. Like the messages will still have a life cycle. The default life cycle will have to go. So we're going to figure out how we're going to go do this. But all the existing apps will work as they do today. So you should not. So that's a problem you should not worry about.
I see. There are a few more questions, but I think we're out of time.
Okay.
Yeah, well, I mean, we can still extend it a couple of minutes, but indeed, let's leave it 2 to 3 minutes to allow people to join the next session.
Okay. I will. Want me to continue asking the questions? 3 questions left?
Okay, well, that should work out then.
Okay. Service Bus has the access key on Service Bus. Is it possible to have the access key on specific queue and topic level?
Yes. You can do that today. Yes, absolutely.
Yes.
And that was possible forever.
And what is the estimated release date for GA for 100 megabyte messages?
We are about to. So the bits are already deployed for public preview. But they haven't been released yet, but it's imminent. And the GA we're looking for before the end of the year.
And last question, are these improvements going to be going to reflect in a better committed base SLA for Service Bus?
The better committed base SLA. So that is a great question. So if it was up to Kevin and Cesar, who's the manager, and Shankar and me, we will probably give you a SLA of 99.995% now. Unfortunately, the SLA is an insurance document that is crafted by lawyers and not by technologists. So we are still looking for ways to kind of surface that up and how well we're doing, so that you can make technical decisions and not decisions based on insurance documents. That's what I'll say about that. So occasionally you'll find me on Twitter leaking screenshots of our dashboards, just to give you an idea on how good the service actually is. And we need to go and find a formal way to go and surface that. But it would be very odd if only Service Bus and Event Hubs did that, and other services would not follow suit. So that's the discussion that we're having. But in general, so I can tell you what our internal goal is. Our internal goal is to run all those services at 4.5 nines. And so that's the kind of the low bar in bad weather. And we typically run them at 5.5 to 6 nines in terms of reliability. And we're still struggling in how to go and surface that in a consistent way in Azure. So the SLO, what I just talked about, right? That's the 4.5 nines. And we'll have to go and we're still working through what that means and how we can go and surface that up to you. But the SLA is the lowest bar.
Thank you, Clemens. We've taken up more time than we should have, but these were great questions.
Thank you. Bye.
Cove.co